So today is September 10th, and you're here for Economics 249. So I'm going to continue with Chapter 3 today. Before I begin, I would like to talk about the email that I sent out. So everyone should have received an email from me with your group contact information. So you had the Excel group assignments. The assignment itself was posted on MyLab, and the email I sent out had each team member's contact information. If you did not receive an email from me, well, couple of things. Maybe it went to the spam folder and that's why you haven't heard from me. Or it's because I sent the email through Blackboard. So whatever email address you have posted on Blackboard or registered with at Queens College, that's the one that receives my email. Okay. Usually I send it through my stat lab, but Blackboard is set up in such a way that it automatically generates groups, and you can actually exchange files and contact your group within Blackboard as well. So again, if you haven't heard from me, if you didn't get any contact information from your team, please send me an email and I will let you know. Questions for me? Okay. No questions about the Excel assignment? Brian, your question is this group for the whole semester? So yes, the group information that I sent you through the email is for the whole semester. So you're asked to take one column with the data set that you picked from the textbook, take one column with data that is quantitative, and try to divvy up the work so that everyone does a little bit, and create your tables and your graphs, copy and paste it onto a Word document, and submit it on Blackboard. Now, Blackboard is set up in such a way that if one team member submits it, everyone in the group gets credit. So make sure when you copy and paste it onto the Word document, I have everyone's names on that Word document. Do not include names of people you've never heard from who did not participate. Okay. And then when I assign Excel number 2 and number 3 and so on, you will be working with the same group. So make sure you have each other's contact information. When I sent you the email, I gave you different email addresses for one individual because that's what I have. So if you don't hear the first time, make sure you send it to all the email addresses. Any other questions? And I think I answered Brian's question. No? Okay.
Professor, is it okay if we work on it on a different platform outside of Blackboard?
Oh yeah, absolutely.
Yeah. Okay.
Yeah, you can exchange phone numbers and all that. Yeah, no problem. And the idea with the teams is, study together, do your homework together, help each other. We're not seeing each other, so at least try to communicate as much as possible. If you don't understand something that I talked about in class and you can't get a hold of me, ask your teammates. Okay. So I'm going to start or continue with chapter 3. And let's see. So chapter 3. So Dong Yan, you asked a question. The Excel assignment itself is in MyLab.
Okay, thank you.
Okay. And Yogita, you said, what happens if you reach out to group members and only half the group are reaching out? Make sure you send an email to everyone on that list that I've given you. Because, if you do it through Blackboard, they might not receive it. Make sure you include all the email addresses that I gave you. The assignment is also on Blackboard. code, Priscilla. You're right. Yeah, because that's where you would submit it. Correct. Okay, so I'm going to go back to this. Okay, so in the last class, we talked about organizing and displaying quantitative data. And I said there's two kinds of ways of doing that, the stem and leaf display and the histogram. And in order to do the histogram, you have to first create a frequency distribution table. And then based off the histogram, you can create a polygon. And then you create a second table, which is a cumulative percentage frequency table, and you create an ogive. So that's what's required for your Excel assignment. Okay, and then let's see, we talked about the stem and leaf display, and I gave you an example. And I think we ended the class with this, these two questions, and we solved these two problems. So this is what we covered in the last class. We stopped at shape. So in today's class, I'll spend time on center, spread, 5-number summary and box plot, and the time series. So let's start with center. So center involves mean and median. So I'm going to start with mean. So another word for mean is average. Now I don't have to spend much time talking about average because you all know how to do that. So mean of a variable, and in your textbook, it uses y as a variable, but I like to use x. I'm used to using x. So in the formula below, you'll see x. So it's very simple, right? The numerator is adding all the numbers together, and then the denominator is this lowercase letter n. And remember, I said way back in the first chapter, n stands for sample size, the number of observations in your sample. So we denote sample size by n. So it's the sum of all the values in your data set divided by sample size. So why do we use mean? Well, it's like a balancing point of a distribution. It gives equal weight to each observation. And mean is very useful when we're dealing with unimodal symmetric distributions. Okay, I want to see if my next slide has what I want to talk about. Yeah, the next slide has an example. So I know that you all know how to calculate mean, but let's take a look at this. The first example says the values are 1, 6, and 2. And if I asked you to calculate mean, so mean, sample mean, is denoted by x bar. Okay, x bar. So like we said, you add all the values together, divide it by the number of observations. Pretty simple to calculate. Your answer is 3. Now, let me give you an example of what 3 could stand for. Maybe 3 is given in tens of thousands of dollars or hundreds of thousands of dollars. If I'm interested in calculating average household income, and I want to calculate it for a particular neighborhood, pretty simple, right? I take the household income for all the households in that neighborhood and I calculate the average. But what if a billionaire moves into the neighborhood and I have this extreme observation, which is completely different from the rest of my observation, and then I calculate mean? Now it's going to distort my average household income analysis. My conclusion is way off. So the second example here shows you what happens when you have an unusual observation, an extremely high observation. So what's the mean? 1 plus 60 plus 2 divided by 3. Shubham, you say 21. Yes, that's right. So I'm going to write here 21. So now 21 is unusually high. It's completely different from 3. So this is saying that when you calculate mean, it's very sensitive to extreme observations. It will shift your average extremely. So we have to be aware of that. Now, on the right, you're looking at this oval shape, which tells you that sample mean is denoted by X bar, the bar on the top. Population mean is denoted by this Greek symbol called mu. So it's pronounced as mu, mu. That's population mean. Okay. So let's move on to median, which is also the center. Now, without reading all this stuff, do you remember what median stands for? Not the medium, but Shubham, you're right. The middle of the set. Kathleen, the middle. Alicia, the middle value. Yes, so that's right. Median is the middle value. So when we take the average, so previously when we did mean, we said it's a unimodal symmetric distribution. But what if your distribution is skewed, or you have gaps, or you have outliers? Then it might be better to use the middle value, the median, because it splits the histogram into two equal areas. So the median is found by counting in from the ends of the data until you reach the middle value. Okay, pretty simple. When you're dealing with 5 observations, you know it's that middle observation. But we also say that median is the typical value. So for example, let's go back to our neighborhood example. Let's say I want to know the different prices of houses in a neighborhood. Now, I wouldn't take the average house price, because what if one house has an extreme value because of some renovations that they did, or built from scratch. So that's going to give me an extreme value, which is going to be changing my average house price for that neighborhood. So rather than average, I would take median house price, the middle value. So that's why in real estate, median is used. It's considered the typical house price in a neighborhood. Now, the problem with median, not the problem. One of the good things about median is that it is resistant to unusual observations. So whatever is happening on the ends don't matter at the center. So let's look at this example here. Now, I did say that when you have, let's say, 5 observations, it's easy to find out what the middle value is. But what if you're dealing with thousands of observations in your sample, or your data set has 364 observations? It gets a bit complicated to start counting from the ends to come to the middle. So we use this formula to calculate median, n plus 1 divided by 2. Okay. And let's look at this first example. The observations are 1, 3, 5, 7, 9. Now I can easily do this. I can look at it and I can say, well, 5 is the middle value. That's my median. But let's use the formula that I gave you. So median is n plus 1 divided by 2. Now n is the number of observations in my sample. So I have observations 1, 3, 5, 7, 9. That's 5. So n is 5 plus 1 divided by 2. That answer is 3. But 3 is not my final answer. 3 is the third position. It's giving me the position. So now I count to the third position. 1, second position, third position. My third position is 5. So my answer is going to be 5. So median equals 5. Let's look at the second example. Now it gets a bit complicated because I have an even set of numbers in my data set. So it's not that easy to figure out what the middle value is. But let me use my median formula, n plus 1 divided by 2. So n in this example is 6 observations. 1, 2, 3, 4, 5, 6. So we have 6 observations. N is 6 plus 1 divided by 2. Now I've got 3.5. Remember, that's the position. That's not the final answer. 3.5 position. So now third and a half position, that means it's the average between the third position and fourth position. So the average of 5 and 7. So that answer is 6. So my median is equal to 6. Any questions? Okay, what if I calculated median and I got the value 3.25? Now, I know that you're doing this manually meaning using a calculator if you have to, or, just without using any fancy technology. So if you calculated median to be 3.25, I expect you to round down to the third position. So we can go with 3, the third position. So the answer would be 5. Okay, this is third position. So my answer is equal to 5. What if you calculated median to be 3.75? If it's 3.75, I expect you to round up to the fourth position. Fourth position. In this case, it would be observation 7. Now, if you were using some fancy software program or even Excel, it will tell you the exact value at the 3.25 position, or the exact value at the 3.75 position. Okay, but for this purpose, it's fine if you round down or round up. Questions for me? Okay, then I have a question for you. So let's do some polling here. Let's answer the first question. Does the mean measure variability? Okay, does the mean variability? Okay, so you should see this question posted. So at this point, I haven't explained the definition or the meaning of variability. I will do that right after you answer this. Okay, 10 more seconds. Okay, and I'm stopping the poll. So it's almost about half and half. So does the median measure variability? So variability means how your data is spread out, how the observations vary from each other. So now what's median? Median is the middle value. Is the middle value telling you how the data is spread out? Is it spread out a lot? Is it spread out a little? Are they close to each other? Median doesn't really tell us that. So the answer is no. Oh gosh, I wrote the wrong thing in the poll, but the answer is still no. Mean does not measure variability either. Okay, so the question is, does median measure variability? And the answer is no. Okay, it does not. It only tells us what the middle value is. So that's one of the problems with median. You don't know how the data varies. You don't know if you have extreme observations. Let's do the second poll. What is the median of a data set with 30 items? So till I get that ready, you can start deciding what your answer is. Okay, you should see that. What is the median of a data set with 30 items? Okay, 10 seconds. Okay, you can see here that most of you got the answer correct. So yes, the answer choice is B, or number 2. It's the average of 15th and 16th observations. So it's not that you don't have, it's not that you don't need the observations itself to come up with the answer. So it can't be number 3, right? Cannot be determined. You can. Yes, Judah, you have a question? So Judah, your question is there any way you can open the chapter assignments in advance? They are open. I have uploaded chapter 3 PowerPoint slides on my lab, so it is available. Okay. Moving on. The next slide is still about center, so still dealing with mean and median, but now we are looking at skewness. So either your distribution is symmetric or it's skewed. That means left skewed or right skewed. So when you're dealing with the distribution that is symmetric, that means the value that you calculate for mean is the same value that you calculate for mode and for median. So when I say same, I'm going to say very similar. So let's say mean, the value was 56. Then mode might be 56.5. Median might be 55. So still very close, fairly symmetric. If your distribution is left skewed, that means it has a long tail to the left, then the value for median will always be the middle value, that center value, but the value for mean will be less than the median, which will be less than the mode. Right skewed distribution, median will always be the center value. Mode will be less than the median, which will be less than the mean. Okay, so this is important. You will have some questions in your homework based on skewness and also for your exam. Okay, so now let's switch to spread. We finished everything with center. Now let's talk about spread. And spread includes range, interquartile range, variance, and standard deviation. So this is starting with range. So when I say spread of the distribution, I'm talking about variability, right? How the data varies. So reading here, we need to determine how spread out the data are, because the more the data vary, the less a measure of center can tell us. So sometimes it's not necessary to look at center because it doesn't give us much information. So we look at spread. The easiest way to measure spread is with range, and you all know how to do this. You take the maximum value minus the minimum value, and you've got your range. Let's look at these two examples. First example has these observations, 7, 8, 9, 10, 11, 12. And if I look at my formula to calculate range, what's the answer for range? Let me pick someone. Xin Ming Wan. What's the answer for range? You can use your audio or the text box, the chat box. Yeah, that's right. So that's 12 minus 7 is equal to 5. Yep. So pretty simple, easy to calculate, easy to understand. Let's look at the second example. The observations are 7, 10, 11, 12, 12, 12. So Sarai, Delion, what's the value for the range? Yep, Sarah, you're right. This is also the same thing, and we also get 5. But there's a problem here. Correct, our calculations are correct. Both these data sets are giving us a range of 5, but we can clearly see that they're not set up the same. They vary from each other. The first example says that the observations are equidistant from each other. The second example says that we have some observations that occur more than once. So all this information is not given to us in range. How do these observations spread out? So we have to look into something else called quartiles. Okay, so moving on to the next thing, we're going to look at quartiles. The quartiles are the values that frame the middle 50% of the data. So the values that frame the middle 50, I'll talk about that in the next slide. It's easier when you're looking at a visual. So quartiles refer to quartile 1, quartile 2, quartile 3, and I'll get into that in a moment. But we also look at interquartile range, which is quartile 3 minus quartile 1. So the difference between the two quartiles. Okay, what am I talking about? Let's look at this next slide. Okay, so looking at the different boxes on the top, let's say we have a set of data, and I take my data and split it into four quarters. And between the first and second quarter, that point is quartile 1. Between the second and third quartile is quartile 2, and then quartile 3. So let's say I calculate the value for quartile 3. That means that value that I come up with, 25% of all the data in that data set is greater than quartile 3. And 75% of all my data is less than quartile 3. So that's giving me some information about the data set. If I calculate quartile 2, it's telling me 50% is higher than the second quartile and 50% is lower than the second quartile. And then the interquartile range, which I showed you in the previous slide, is Q3 minus Q1. So let's do this example together. I know that you can see everything here, but the next slide really breaks it down. So I'm going to move over to the next slide and use these same numbers. So this is what we're looking at, right? Let's say I gave you this data set with these observations, 11, 12, 13, 16, 16, 17, and so on. Step 1, rearrange your data into an ordered array. So is this an ordered array that you're looking at? Are you sure? Yes, so that was just a trick question. It is an ordered array. Okay. So the next step is we're going to calculate quartile 1. Now this formula that you're looking at here, that's the formula we use to calculate quartiles. So Qi is equal to I times n plus 1 divided by 4. N, we already know what n stands for. It's the number of observations in your sample. I stands for the quartile number. So if I want to calculate quartile 1, then I would be 1. If I want to calculate quartile 3, I would be 3. So what I'm going to do now is I'm going to ask a couple of people to help me out here. So Purushottam, can you calculate quartile 1? Tusha, calculate quartile 3. And I'll help you along too. And then yin yang, calculate interquartile range. Okay, so let's start with Q1. Now for Q1, I have to look at my quartile formula, which says I times n plus 1 divided by 4. Now I is 1 in this case. What is n? Tyler? Stellan, you say 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. So that's 9 plus 1, the whole thing divided by 4. So what you get for the answer? 2.5, yep. Okay, so just like we did with median, this is the position. 2.5 is the position. So Mark, what do you think? If it's 2.5 position, what's the actual value for quartile 1? Yep, so you did 12 plus 13, and then the whole thing divided by 2, and you got 12.5. Yeah, any questions for that? It's pretty simple, right? That's fairly straightforward. Let me calculate everything, and then I'll explain what this means. So the next one was Tusha, right? So you're doing third quartile, so I is 3 times, and you said n is 9 plus 1 divided by 4. What's the value you got, Tusha?
I got 6.75.
Let's see. Okay. So 3. So do n plus 9 plus 1. That's 10 times 3. 30 divided by 4 should be 7.5, right? Just check your work again. 7.5. Yeah. Now that's the position. So can I have? Did you have a question for me?
No, I forgot to add the 1.
Okay. Zhao Chen, Zhu last name. What's the position? 7.5 position. So Zhao Chen. If you don't have the answer, okay, yep. So I'm seeing different numbers pop up here. 7.5 position should be, so let's count this together. 18 plus 21 divided by 2. Just making sure you guys are getting it here. Yeah. Let's count this together. 7.5 position, this is the first, second, third, fourth, fifth, sixth, seventh. So 7.5 should be right here. So that means 18 plus 21 divided by 2. That's 19.5. Okay. So now what is this telling me? This is telling me that with a quartile, if quartile 1 is equal to 12.5, 12.5, so that's this. So in my data set, with this particular data set, if I have a value of 12.5, that means 75% is greater than the value 12.5, or 25% of my data is less than 12.5. If I look at quartile 3 and my value is 19.5, which is here, this is telling me that 25% of my data set is greater than 19.5 and 75% is less than 19.5. And then yin yang, you were going to calculate interquartile range. Yep, that's right, 19.5 minus 12.5, and that's equal to 7. So make sure when you're doing this, you don't take the positions and subtract them, take the actual values. Okay, so now what is interquartile range? Okay, well, it's telling me the difference between Q3 and Q1, but if I look at my visual, the 4 quarters on the top, it's saying interquartile range is the middle 50% of my data. The middle 50% of my data. So it really tells me the chunk of what's happening in the center. So remember, you have to rearrange your data in an increasing order, and then it doesn't affect what's happening in the extremes. So interquartile range is very important because it tells us the middle 50% of what's going on in the center. Do we need to use quartiles, interquartile range? Where are we using it? I'll give you an example. You all took your SATs before you joined, before you applied to college. And let's say, for example, your exam score placed you in the 75th percentile. Okay, your SAT score placed you in the 75th percentile. What does that mean? Do you remember taking the SATs? Okay, yep. Shubham, you said you're compared with others. So Stellan, you say, if your SAT placed you in the 75th percentile, that means you scored higher than 75% of the people who took the SAT. Correct. Yeah. So that's actually a quartile. That 75th percentile is actually quartile 3. Whatever score you got is that Q3 value. And that means 25% of the people did better than you, or you did better than 75% of the people. So quartiles are used frequently. Okay, let's move on. We have a polling question here. So let's do this together. Till I type it in, you try to figure out the answer. So this is the question. A large interquartile range indicates a small spread of data. So think about what interquartile range really means. It's that middle 50% of the data, right? I'll give you 10 more seconds. Okay, and let me show you how the responses went. So again, about 50-50. Okay, so I think the best thing for me to do is to go back to our visual to explain that. Okay, so I'm going to do that. So this is our 4 quarters, and the question asks you about the interquartile range. So a large interquartile range indicates a small spread of data. So if I calculate IQR and I get a huge value, what does that huge value mean? It means that the way the data is spread out in the middle is huge. It's spread out a lot. So this answer is false. A large interquartile range should indicate that it's spread out a lot. So that means, let me move to the next slide. This answer is false. Kevin? Yep. Okay. So let's look at this oval thing in the box. I have to make a point here because I showed you how to get quartiles manually, using a calculator. That's fine. So manually. Now, in your homework, there are 2 questions that you're asked about quartiles. First question says, calculate quartiles using technology. So what do they mean by technology? That means using Excel or some other software program. So what you do is in Excel, or if you have Google spreadsheet, same thing, you type in this formula. First the equal sign so that Excel knows that you're typing in a formula. You type the word quartile, then highlight the range of the values that you're interested in, all your observations in the data set. So for example, from cell A1 through cell A25. So you might not have it in these cells, but this is just an example, comma, the number 1. Now this number 1 indicates that I'm interested in quartile 1. So if I wanted quartile 3, I would type in 3. Another question your homework asks is calculate quartiles using Tukey method. That is the method that I just used in lecture today. So that's a more manual method. The difference is, let's say your value is 5.25 for the second quartile position, 5.25 position. Now I said that you would round it down. That's the manual way of doing it. But Excel would actually give you the 5.25 position and the actual value of that quartile. Okay, so just be aware when you're doing your homework. Questions? Okay, so still talking about spread or variability, the next thing is variance. So this is variance. Now variance plays an important role in measuring spread, but the units are the square of the original units of the data. So why do we even bother with variance? Why aren't we just happy with quartiles and how that calculates the spread of our distribution? The thing is that when I look at quartiles, I'm more interested in interquartile range, and that uses 2 quartiles of data. It really ignores information on how individual values vary from each other. So for that reason, we look at variance. The formula that you're looking at is sample variance. So sample variance is denoted by S squared. If we look at the population variance, it's sigma squared. That's a Greek symbol you're looking at, sigma. So now in your textbook and your homework, it keeps using the variable y, but I like to use the variable x. So it's the same thing, but it would be x. So the sum of x minus x bar squared divided by n minus 1. Okay, so this is sample variance, the formula. It's not that complicated if you break it down in parts when you're doing variance, and I can show you that in a moment. So let's go back to our original example. The values are 1, 6, and 2. So this is my formula for sample variance. So I'm going to look at this formula to try to figure out how to calculate the variance for observations 1, 6, and 2. So the first step is to get the average or the mean. Okay, so one more thing I have to do first is I'm going to fix this. Whoops. So I'm going to fix this into x because I'm used to using x. Okay, so first thing I'm going to do is calculate my x bar, my mean, sample mean. So that's what this value is. So we have 1 plus 6 plus 2 divided by the number of observations 3, which is equal to 3. So we have x bar. Second step is to look at what's in the parentheses that I have to get. So I need to get x minus x bar. I need to get x minus x bar. So I'm taking the first observation, which is 1, minus the mean of 3. Then the second observation, which is 6, minus the mean. The third observation, which is 2, minus the mean. And then I have -2, 3, and -1. Next step is to get the squares. So the whatever is in the parentheses squared. So that would be -2 squared, which is 4, 3 squared, which is 9, -1 squared, which is 1. Step 4 is to get the sum of all those squares because that's what this sigma value is, right? This Greek symbol sigma. So that's my sum of everything in the numerator, and that's 14. And then finally divided by n minus 1. Again, n is my sample size, which is 3. So that answer is 7. So now variance is equal to 7. So sample variance, S squared, is equal to 7. So it's not that difficult if you break it down and really try to understand what it is. And I can see here, according to the formula, it's telling me how much each value varies from really the average, how much it varies from the center. Does it vary a lot? Does it vary a little? Now, we came up with this number 7. At this point, I can tell you if 7 is a large number or a small number. So I don't know if this variance is big or small. Does it vary a lot or a little? What I can say is that if I take this data set with these observations, 1, 6, and 2, and I compare it to another data set with different observations, and then I calculate the sample variance for that data set, then I compare the two variances and I can say, well, this varies a lot, this varies a little. So that brings me to the next slide for you to answer this question. Okay, I will be loading it up in a moment. So the question is asking you, does data set A or B have more variability? I'll give you 10 more seconds. Okay, I'm stopping the poll here. So you can see most of you chose A, and the question is, does data set A or B have more variability? Now you know that variability means spread, how the values are spread out. So yes, answer choice A is correct. It is more spread out than B. Now my next question is, comparing A and C, what do you think about variability with A and C? About the same, about equal, similar. Yes, I agree. So A and C are about the same. Now, they all have this distribution that is symmetric. They're all symmetric. The center for dataset A is the mean, and the center for dataset C is the mean. So I can say by looking at this is that the mean is higher for dataset C and lower for dataset A. The mean is higher in dataset C. I can also say that the mean is the same for dataset A and B, although A is more spread out. A has more variability. So in other words, if you calculated the sample variance for dataset A and C, it would be the same. Sample variance for A and B, A would have a larger value than B. Okay, moving on to the next slide. So based on sample variance, we can also talk about standard deviation. So standard deviation is just more specific rather than variance, because with variance, we were taking the units that were the square of the original units. So this is, once you take the square root, you come up with a value that makes more sense. So that's why we use standard deviation. So it's the same formula that you're looking at, but square root of the variance. So I know this is not very clear here, so I'm going to write it here. It's the same example from before. So we had the values 1, 6, and 2. And then I said that the variance that we calculated was equal to 7. So if I ask you now to calculate the standard deviation of this same set of values, you would take the square root of 7, and what's the value you would get? Xiao Chen. Oh, I asked you before, sorry. Shamia Michael, what's the square root of 7? So not the square, but the square root. Yep, Diana, I think you got that right. Now I'm going to be a little bit more specific and give it to you in 3 decimal places. So 2.646. I would like you to get into the habit of using 2 or 3 decimal places. Be very careful when you're doing the homework. See what the question is asking you. If it asks for 3 decimal places and you put 2, it's going to mark you wrong. You'll get the entire question wrong, even though your answer might be correct. Okay, so be careful of that. The oval that you see here in the yellow, this is telling you that you can use Excel to calculate standard deviation. The example that I gave you only had 3 observations. What if you're using all the values in your data set from Excel, that Excel assignment? Some of you might have 50 observations, some might have 200. So I don't expect you to do this manually. You are allowed to use Excel. You're doing this whole thing online. I expect you to have a spreadsheet open. You can do it for the homework. You can do it for the exams. So this is the formula for standard deviation if you're using it in Excel. You type the equal sign so that Excel knows it's a formula. Type the words stdev.s open parentheses, and the range of the values that you want. So from A1, cell A1 to cell A25, which might be different for you. Questions? No questions? Okay, we have some time, but I'm not going to continue with the rest of the material because I would like to spend some time on Excel. Does anyone have any questions for me on the Excel assignment? So I'm going to end class a little early, but the rest of the timing I'm going to spend answering your questions for the Excel assignment. So specific questions? Can you give us an example? Okay, I'm going to try to share my screen. I know that there were problems before when I was trying to share my Excel screen, so I had to do screenshots. Okay, so till I do that, let me answer the questions in the chat box. First question is, only one person has to submit it, correct? Yes. Only one person in your team submits it on Blackboard. So what you do is everyone do their part, copy and paste onto a Word document, put everyone's names who participated, and one person submits it through Blackboard. And everyone automatically gets credit for it, whoever's on the team. Okay, next question is, are the instructions posted? They're posted on MyLab and they're also posted on Blackboard. Okay, it says Excel 1 assignment. So you should be able to see it. Do we email you the data that the groups are going to use? I would like to know which data set you're using. So if you can email me that data set before you start analyzing everything, that would be super helpful. So at least I'm aware before you start. Any other questions for me? Okay, I'm going to try to share. Okay, let me first open. Okay, give me a moment here. So sharing an application. Okay, hopefully this works. Oh, good. Okay, so everyone can see this. It's quite clear, right? Good. Okay. So on Excel, I'm going to put a few values, and let's say, so what I'm going to do is I'm going to create a frequency distribution table with my data set. Let me just go back to this. Okay. Let's say I have the values 53, 24, 26, 12, 17, just making them up, 30. Okay, so the first step is to rearrange my data in increasing order. Now, I don't have to do this manually. I could do it in a couple of different ways. I can just highlight this, or I can highlight the entire column, and I can go to Data and click on A to Z sort. So it's asking me, do I want to sort from smallest to largest? Yes. So I'm going to click on that, and then you can see it automatically rearranged my data set in increasing order. Next thing I'm going to do is to set up my column titles. So we said class, frequency, relative frequency, and percentage. Okay, let's make these columns a little wider so they're not overlapping here. Okay, and then my first step was the ordered array. My second step was to decide on how many groups I wanted. So let's call it G. And I said usually we take 5 to 10 groups. I decided to go with 5 groups in that example. Okay, so my number of groups is 5. Third step was to decide on the interval. Now, according to the formula, you take the highest value minus the lowest value and then divide the whole thing by the number of groups. So in this data set that I'm looking at, I have 53 minus, what's my lowest value, Urmila? Yeah, it's 12. Okay, so minus 12 divided by 5. And then Yogesh, what do you get for this answer? Yeah, we get 8.2. So it's a bit complicated if I go with 8.2. So I decided to go with 10. Okay, I'm going to round it to 10, something easy to work with, an interval of 10. I know that's not exactly the correct answer, but it's close enough to 10. So now I'm going to say I need 5 groups. Let's start with the first group. 10 to 20, that's an interval of 10. Then 20 to 30, 30 to 40, and so on, right? So we have 5 groups, 1, 2, 3, 4, 5. Go here, let's put some color in here. Okay. Next thing is frequency. So with frequency, I actually count how many observations fall from 10 to 20. So in this situation, there's only these two values that fall in 10 to 20. So that's 2. My frequency is 2. From 20 to 30, and not including 30, that would be these two observations, right? So let's pick that. So that would be 2. And so on. This would be 1. And I'm just making up numbers now because I don't know what the rest are. So that's that. Then this would be total, right? This whole row would be my total row. So let's make this a different color. Okay, I need to calculate the total for frequency. So I click on the sum button and it's asking me if that's the range I want. So it is correct. So I hit enter and it tells me that the total in frequency is 16. That means I should have 16 values in my data set. Okay, I made this up so you don't see 16, but there should be 16. Next is relative frequency. First thing I do is I type the equal sign so that Excel knows this is a formula. And I tell Excel, take whatever is in this cell and divide it by 16, the total for my frequency. Now your values will be different, but it's the same method. And I hit enter. And then I copy and drag this all the way down. And that's the answer there. If I click on any one of these cells, I can see here that the formula box shows me what the formula is. Now, what should my total for relative frequency be? Yes, that's correct. It should be equal to 1. So let's see, let's get the sum of this, and I hit enter. That should equal 1. Percentage is spelled wrong, right? Okay, and for percentage, same thing, equal sign, take whatever is in this box times 100. And I hit enter, and that gives me the percent. Now again, I'm going to copy and drag it. Be very careful when you're copying and dragging because there's 3 different ways of having this icon here. If I use the mouse at the bottom right, it's a fill handle like a plus sign. which is what I want. If I use the mouse in the center, it just highlights. If the mouse is with the arrows, it's going to move the cell. Okay, so this is what I want, copy and drag, and this should total 100%. So I've created my frequency distribution table. Shouldn't be that difficult. Next thing is to create my bar chart, which is actually a histogram, right? So I said in the notes and the instructions in the last class, highlight class as well as frequency. Now, when you highlight it, include the heading, but do not include the total. You don't need the total in the graph. So you highlighted those two columns, then go to insert. It's this bar chart. So click on the 2D column is fine. So I click on that and I've got my histogram. First thing I'm going to do is change this title because this is my histogram. And what should I do to fix the graph? Yes, change the spacing, move them closer, close the gaps, exactly. So I right click on the vertical bars, click on Format Data Series, gap width, change that to 0, and then close it out. So immediately it's fixed. Now I have a histogram. I would like to add titles to my axes. So I click somewhere on the chart. Okay, I clicked it. Click on Chart Tools, add chart element, axis title, primary horizontal. Okay, my primary horizontal, this is, okay, it's not letting me do anything here. Let's see. Kind of stuck. Okay, not sure why it's not letting me. Oh, okay. So add chart element. Not sure why it's taking a while to do this. Okay, there it worked. So I changed this to class, and then I want to add my vertical axis, which is frequency. And now I have my histogram. If I want to create a polygon, I can just copy this and let's paste it here. And now I change this into a polygon. So let's change the title first, polygon. And then I have these vertical bars. So I right click the vertical bars, change series chart type into a line graph, and I say OK, and that's my polygon. Okay. So what I need you to do is copy this, paste it onto a Word document, copy this, paste it on a document. If you're creating the second table, the cumulative percentage frequency table, you were asked to highlight two different columns. Class is one column, and let's say you had created cumulative percentage frequency in this column. Now you can't just highlight everything because it takes it simultaneously or consecutively, sorry. So you highlight class, hold the control button on your keyboard, and then highlight this. And then you can go to insert bar, 2D bar. Okay. Any questions for me? Okay, so I'm going to stop sharing here if there are no questions. And I will end class today. So you can always email me. Remember, the Excel assignment is due on the 17th. Your homework is due this Sunday. The data set that you pick from the textbook, that's where I would like you to take the data set from. Okay. The data size it depends on the data set that you pick, right? So to answer your questions, Urmila, the size doesn't matter. It's which data set you're picking. You're only choosing one column from that data set. Okay. Any other questions? Okay, you're welcome. Enjoy the rest of your day.